Imagine fitting a battery onto this contact lens. What will it look like? What can it do? Well, now researchers in Singapore have developed an ultra-thin battery that can be embedded onto your contacts, transforming them into smart contacts. The best part, it could be powered by your tears. Let's go see how that works. For over a decade, companies around the world have attempted to create smart contact lenses, but they never got down to incorporating electronic components to make a safe battery. Inspired by a scene from the Mission Impossible film series, Associate Professor Lee Sok-woo has taken his expertise in batteries to address the smart lens's power supply issue. He leads the battery development team at the Nanyang Technological University's School of Electrical and Electronic Engineering. Professor, thank you so much for having CNBC here. Can you tell us more about this technology that you're working on?
So, when I decided to work on the smart contact lens and the power supply to the smart contact lens, so I was concerned about the safety because the lithium-ion battery has the issue of the explosion or catching fire. So I was thinking about how I can make ultimately safe battery. Then I realized that tier solution also can be the electrolyte because this solution contains sodium chloride, so salt. We replaced the flammable organic electrolyte with this tier solution. Then we developed the electrode material working with these salt ions and then implanted this electrode inside of the contact lens, which means we can save the volume of the battery.
The battery is as thin as 0.2 millimeters, and it fits onto a 0.5 millimeter lens. To test that it doesn't obstruct the lens user's vision, Professor Lee's team has an artificial human eyeball which mimics the real application of the smart lens.
We don't want some particles floating around on the eyeball, so we have to guarantee the mechanical strength of the lens. That's why we decide the thickness of the battery as a 0.2 millimeter.
How much electricity can it store?
So currently the output voltage of our battery is around 0.6 to 0.5 volt. This is not enough to operate the conventional electronic device. So now we are working on developing new electrode material which can provide higher voltage output and higher capacity.
So how is the battery charged? Well, there are two ways. The traditional method,
just connecting wire, like charging your smartphone. We need to have a metal pad exposed outside of the contact lens hydrogel. Then it might be contact with another electric pad while you are taking off the lens.
And the chemical method.
We found that the glucose can charge our electrode material. We coated enzyme working with glucose on the electrode, and then we put the contact lens battery inside the container and we added a certain concentration of the glucose solution.
Conventional charging allows the battery to be charged up to 200 times, while glucose only allows for 15 times. After 8 hours of charging in the glucose solution, the battery will reach 80% of its full capacity, and then it can be worn for a couple of hours during the day. Since tears contain glucose, they can also power the battery. For a demonstration of how this technology works, I spoke with Lee Jong-kang, a PhD student and part of Professor Lee's research team.
I'd like to show you the output voltage of our device. We can use this to show the voltage of the lens.
0.3 volts, is that correct?
Yes, because this one is biofuel charge, and if you immerse it for a longer time or if you charge it electrically, the voltage will be higher.
The lens's electrode is made of a blue pigment similar to the one found in the jeans that we wear, and it can help identify high glucose levels.
This lens is our lens for power-free glucose sensing. Here you can see it has 4 blue patterns, and when you put it in your eyes, will have color change, higher glucose level, more blue.
Unlike traditional contact lenses, smart contacts have the potential to do more than just correcting the user's eyesight.
You can also monitor the health or disease to detect the signal from the tear solution or eyeball.
And when it comes to augmented reality, data storage, and overall connecting our eyes to the internet,
The smart contact lens has a limited volume. This need to contain display, especially for AR applications, and will contain the minimum computing power. So it might be hard to implant all of the devices in the one smart contact lens.
as with every new product that enters the market, this technology comes with challenges. The biggest one is the space limitation of the lens to fit a bigger battery. And of course, the technology needs to be patented first before these smart contact lenses become a reality.
This game-changing innovation certainly has exciting possibilities for the future, potentially transforming the way we use and apply something as commonplace as contact lenses. And while the research is still ongoing, it's a technology worth keeping an eye on.